Okay. No more hardware, I think. Okay. So next presenter is Wei-Hsiang. Sorry for my bad pronunciation. And the title of the paper is Fire Evacuation and Management Model based on Building Information Modeling and Virtual Reality. So
Hello.
please, you can share your screen.
Okay.
Okay, thank you. And we can check before to start the audio if from the auditorium they can hear you well. I can hear you very well. So you can check in a few seconds. Okay, I can see your screen.
Okay. Then can we start?
Yes, you can start. Thank you.
Okay. Hello, everyone. I'm Wei-Hsiang from Department of Civil and Construction Engineering, Chaoyang University of Technology in Taiwan. My topic is fire evacuation and management model based on building information modeling and virtual reality. And it's outlined. The following 5 points will be used to outline this research. And the first is introduction of my topic. The second is literature review. The third is about the BIM and VR-based fire evacuation and management model. The fourth is case study, applying the integration methods to actual cases, and that is conclusion will explain the actual use result of this research in 2 points. Introduction. In recent years, the frequency of fire in Taiwan has increased. Fire occurred causing death and property damage. Therefore, tragedies can be reduced by implementing disaster prevention measures. And to improve the efficiency of fire education, VR technology can be incorporated to support evacuation training for the public. And BIM can be employed in setting the parameters for firefighting equipment models and achieving the implementation of the equipment maintenance and management. And this study incorporated optimal evacuation route guidance into a VR system to reduce accidents caused by prolonged evacuation time. This study also used VR to simulate the emergency stress that personnel cannot experience when they are performing an evacuation drill in a safe environment to improve their emergency response to actual disasters. A literature review. The first point, she established a disaster prevention management model on the basis. Increase emergency response efficiency and reduce casualty rates and property loss, thereby achieving the goals of disaster prevention management. And second point, the integration of the life cycle information of building is a challenging task, so it should be retrieved through BIM software. Showing et al. Proposed the building fire information management system. This system enables emergency responders to intuitively identify the location of indoor facilities. VR evacuation simulation. Cho use fire simulation model to estimate the time required for evacuation under varying conditions. The final simulation result was consistent with the results obtained by other researchers who used other fire simulation software. This indicated that the Unity software can be used in disaster prevention simulation. Second point, Wang et al. Employed a BIM VR-based virtual environment and a game engine to solve the key challenges in building emergency management. They combine BIM and VR technology to create applicable and immersive game environment. Chen et al. Developed an accident on software oil and gas platform simulation model in which evacuation plans are evaluated through BIM to improve evacuation technology and achieve an enhanced engine-based model. and navigation function of Unity. The navigation function of Unity game engine can be used to create a navigation mesh that serves as the moving area of the engine on the basis of geometry. The engine then simulates movement behavior and control a character to cause it to move toward a target. The factors that should be considered in the navigation function are speed, angular speed, acceleration, and stopping distance. The setting for each parameter is determined based on the needs of the navigation process. Being VR-based fire evacuation and management model. In the study, there are built the most basic house elements, including columns, beams, slabs, and walls. To make the model look more realistic, it adds light and shadow effects. Since then, several techniques have been used to simulate what should happen in the event of a fire, not only to allow people to experience the escape route in person, but also to simulate the effect of blurred vision due to smoke. In the study, it also used the allowable evacuation time in the literature to determine whether the time simulated by the software is within the calculated allowable range. If representing the simulated path is safe and useful, these programs can provide users with an experience that traditional training methods cannot provide. In addition to their practical use, if this study is used in VR-based evacuation education, it is expected to have the effect of reducing damage and costs. The case in the study was a four-story duplex. This study combined the building information model of the duplex with a fire management and maintenance VR system. The test process is described in the following subsection, and we can see the figure. The picture showing rendered model with light and shadow added through Unity. Case study, BIM module. The case model had basic elements. In addition, to improve the maintenance and management module into the VR system, firefighting equipment maintenance information was added to the model parameters. VR environment. This study rendered the model and added light and shadows through Unity by making a shader. This study then added the shader to the model element for reattachment and set the lighting effect to increase shadow detail. With the Unity Light Matte function, the realism of scenes can be enhanced. Evacuation route module. The navigation function in Unity was applied for mesh map backing. The engine would move to the safe area according to the script function, and the system would record the overall time people spent to move to the safe area. Subsequently, the relevant evacuation information was exported by using the schedule export function in the building information model. This study verified whether the actual evacuation time of the engine was within the limit of the allowable evacuation time calculated. If the actual evacuation time calculated using the VR system was shorter than the estimated allowable evacuation time, it can assist the engine to evacuate safely. Educational training module. After comparing the actual evacuation time with the allowable evacuation time, this study verified that the evacuation route recommended by the VR system was a feasible route. On the basis of this finding, this study created a navigation engine that guides users to evacuate to a safe area. In addition, the Unity protocol system was employed to simulate an actual fire scene and increase users' feeling of tension and stress. Conclusion. In the present study, this study proposed a VR-based fire evacuation and management model. Through the integration of the building information model and VR technology can use of the navigation and script function of Unity. The game engine was able to move to a safe area by taking the shortest evacuation route. This study set the navigation engine to assist users in identifying an evacuation route during a fire. Then this study simulates smoke to increase users' sense of tension and stress during a simulated fire scene, and also enabling users to understand information. Future studies indicate the physical and mental factors associated with dangerous situations. This study is not considered. Future studies should include the two factors to enhance our proposed fire management model. And thanks for listening.
Okay, good. Thank you very much, Han, for your good presentation. And I would like to ask to the audience if there is any question, any clarification to Han. No question in the chat at the moment. Any question from the audience? From the auditorium? I think not.
No, here we don't have questions.
Okay. I can ask you a quick question. I think that the topic of simulation in game engine is very relevant, and this kind of application in fire emergency as well, very important field of application. My question is, why did you choose game engine and not another platform, not another technology for carrying out this kind of simulation, just for complete the motivation, the background? So just for that, thank you.
Yes, this is a good question, but sorry, I don't know the answer.
Sorry, I'm also one of the author, and I'd like to answer this question. Because we choose game engine as the software because we think it can follow how we like the simulation goes. We can use some coding to develop some more functions we like. Yes, that's why we choose game engine as the software.
Okay, so do you mean some embedded function that can be used as it is to provide faster results to the simulation?
Yeah, compared with the software, the software is sold in the market. We use game engine to develop the system, so we can interview how the industry would like to have the simulations like, so we can develop the systems like that.
Okay, it's clear. Yeah, I agree with you, and I think that game engine is a great technology for this kind of simulation. Okay.
Yeah, thank you so much.
Thank you very much.
Thank you.
Thank you. If there is no other question, we can. No other question, right? Okay. No question in the chat. Okay. I think that we can close this session. I would like to thank you all for your participation. Thank you to all the presenters for really good presentation and for being within 10 minutes limits. So, okay, there will be a break now, a coffee break now, and next session is session C2, human factors and human system collaboration. So thank you again and see you in next session. Thank you.
Okay, so just a quick reminder, we will continue the next session at 3:30 p.m.